Hi, today I'm going to begin this series of videos dedicated to application of Radio Equipment Directive to IoT devices and anything that uses intentional transmitters in the European market. The scope of these videos is too large to cover it in just one, so specifically today we're going to talk about radiated spurious emissions, and in later videos I will also cover the calculation or measurement of electromagnetic field exposure, as well as electrical safety and other generic standards dedicated to electromagnetic compatibility of radio devices under various standards. To keep this series practical, I will also show how to perform all the tests in a controlled environment in radio performance testing facilities and OTA chambers. But for the first part of this video, we're going to talk about the standards behind radiated spurious emissions testing. So if you only want to see the practical aspects of it, feel free to skip over this part. So for the determination of spurious emissions, we need to look into another generic standard, which is the ETSI 32908-1. And that tells us the spurious emission requirements for user equipment devices on cellular networks. And basically, the most important part of this standard for us is effectively this table right here, table 4.2.2.2. So this table is actually based on several ITU recommendations that are applied everywhere, and except Americas, of course. And if we'll open the ITU SM.329 recommendations, we'll see that it specifies the limits for emissions in the spurious domain for all kinds of devices. Not just the user equipment, such as IoT devices, but also the base stations. And it defines all those limits for the frequencies up to 300 gigahertz. And under SM.329, there are several categories of limits that apply to all sorts of equipment. But we don't really need to look for all that, because ETSI have already done this job for us. And as we're only looking at the user equipment, which is really all kinds of equipment that is not a base station. So if we look at this table, we'll see that the different limits for idle mode and active traffic mode. And the difference between idle mode and active traffic mode, well, obviously that in the active traffic mode, the device must be transmitting consistently and measuring the bare error rate of the transmitted signal. Whereas in the idle mode, you still need to establish the communication link and then switch to standby. It's quite important that you do that and not just leave your device completely turned off. Those limitations are based on the carrier frequency, or rather the upper frequency edge of the uplink operating band. In LTE, those bands are defined through yet another standard, ETSI TS 136101, which is based on 3GPP standard. And those basically standards specify what exactly those bands should be, and it's quite a lot of information here. But what we also can find out from it, and this is referenced in this adaptation, which is TS 136124, is the exclusion bands that we need to apply during the testing for spurious emissions. and those are defined right here. So there's section 4.4 receiver exclusion band is something that the test operator needs to set prior to commencing the radiated spurious emissions testing. Of course, there are so many bands, in fact 88, it will depend on your device which one it will actually be using and which one you will be testing, but you do need to test all of them. You can't just test one and not test the others. So you have to test all of the ones that you're actually going to be using in a real-world scenario. So going back to the table, we can then deduce the upper frequency range of our test by figuring out what's going to be the uplink frequency. So for example, the band 1 would have the uplink frequency of 2.1 gigahertz approximately. So if you multiply that by 5, you will see that this frequency is 10.8 gigahertz, so it is below 12.75 gigahertz, and that means that you don't have to do the testing above 12.75 gigahertz. Whilst otherwise, it will just carry on up until 300 gigahertz, and you will have to comply with the limits here. So following that table, there are also some guidelines that are applicable to how this testing shall be performed, which are specified here in the section under test method. And that tells you that the EUT shall be placed in an anechoic chamber and rotated to obtain the maximum ERP response. And in fact, there is a difference between ERP and EIRP, and that difference is constant 2.15 dB. That is related to the difference between isotropic antenna and a half dipole, which is the real antenna. Then there are a few other important considerations for how to set up wireless call box, and that is that the testing has to be performed in QPSK modulation mode because it gives the highest EIRP among others, such as 16 QAM. Then the second one is that you have to test low, mid and high channels, not just one on each band, but all three of them. And finally, it's also telling you the resource block allocation, that in a uplink you must use one resource block. So it would be one in low mode, one in middle mode, and one in high mode. And then for downlink, you would set resource block to 50. Finally, the test channel bandwidth should be 10 megahertz, and all of that is for the default class of UE transmitters, which have 23 dBm transmit power limit. So I think this is all that I wanted to talk about in this introduction section, which ended up being quite long because obviously it's a very delicate and complicated topic, but now we can go to the test house and witness the testing itself. And this is the test setup we're going to use for spurious emissions testing today. And as you can see, it's got to be very tall. ETSI spec actually tells you to test spurious emissions at 1.5 meters, and FCC goes even higher to 1.8 meters. So you really have to have pretty long arms if you want to be a radio test engineer. Spurious emissions testing usually takes about 10 hours to complete if everything goes well, and that is because you test in each band, and each band is analyzed for out-of-band emissions and against the ITU recommendation. So it is quite a delicate and time-consuming process. You can actually see it blinking through the cover. So that tells me that it's now connected to the Anritsu, and we can begin a testing. And on this end, we know it's connected when we start seeing those kind of numbers. So this is what was missing previously. Now we can begin the measurement. So the way it works is that you can go to different boxes, and there you go. Now we have a much better constellation because we do a single measurement. Oh, where's the fourth one gone now? There you go, he's back. And yeah, you just click single measurement. It's actually quite intuitive. So many settings here. But so yeah, so the power measurement as well, we can measure it. So it's obviously gonna be quite matching with the UE power we have been seeing all along. And another interesting screen, where is yeah, back to this. Another interesting measurement we can do is a measurement of throughput, so that's pretty cool. And yeah, now we can see that the throughput is 2 megabit per second, actually, isn't it? 2000 kilobit per second is equal to 2 megabit per second, as far as I know. And upload 72. So yeah, I don't have a particular goal in mind, but that's what we're gonna do. And yeah, you can see now this is actually quite important, and it's part of the ETSI and FCC testing, is the occupied bandwidth testing. So that looks pretty good to me, really. So all measurements we're actually going to do with a spectrum analyzer and the log antenna. So we did a little estimate. We found that the transmit power is not very different across different bandwidths. So at 3, 5 and 10 we have recorded the received power level. So we'll just proceed to use 10 megahertz as a bandwidth and use that for spurious emissions testing on all bands. Oh, okay.
I was worried.
I was started getting exciting.
No, it's still way below the limit.
So we can set the output level here, and that corresponds to the downlink transmission. Actually, the uplink transmission we don't control, and that's basically configured automatically by the modem, and by default is set to plus 23 dBm. So we don't do anything about it, we just test it at plus 23 dBm. So when testing the EUT in idle mode, we can see basically all the peaks from the power supply, which this is a peak scan, and in the peak scan they're quite close to the limit, but now it's doing the average measurement, since that's what this ETSI standard is telling us to do. And so we are anticipating those peaks to come down, but even with a peak scan it was still under the limit. So the threshold, the red line, in idle mode is minus 57 dBm, which is more strict than in the active traffic mode, which was minus 36 dBm. So yeah. Is it gonna update itself when it's finished? Oh yeah.
So you can see the emission for number 1.
Yeah.
As once you 71.95.
Oh, I see. Yeah, so that's 62.3, no? Yeah, but still it's significantly lower as a limit. And others are now gone to minus 70 dBm. So it's a pass. That's all we want to hear. So now doing the Spurious emissions up to 8 GHz, from 1 GHz to 8 GHz, so you can see little spikes, but the limits are now a bit different, so the limit is minus 30 dBm. So at the moment we see that quite low, and it's a comfortable pass. There you go. So that's how much below the limit is. So this is a horn antenna we use for the testing from 1 to 8 gigahertz. You can see this distance is a lot shorter now to the DUT. So this is a completely different type of antenna we use. Double reach kind of horn antenna. Oops. And what's interesting about Spurious emissions testing, so this is the antenna we use to connect the call box, but this is only to create signal in the downlink, but the actual measurement of Spurious emissions is performed with the spectrum analyzer, and that is connected to the antenna, to the large antenna, which goes up to 4 meters in height. So this is what you've been seeing on the previous videos. This is effectively the test setup. Again, 1.5 meter distance. So a spike actually. I think my light. Yep, nothing much. So this is the last antenna we're going to use, and that's another horn antenna that is specified in another ETSI TS 150, I believe, standard, that tells you that for this range you use horn antennas rather than logarithmic dipoles, and this one goes between 7.5 and 18 gigahertz in operational frequency. So we're gonna be testing up to 12.75 gigahertz today. Yeah, nothing else has changed in setup. There you go. So in high frequency ranges, so where are we stopping now? 1275, is it? Yeah, 1275. Yeah, from 8 to 1275. Basically we've got nothing at all, so that's what we would expect, and we're just gonna repeat that for where.
So this is band 1 transmit?
Band 1 for other bands and other orientation. So at the end of the testing, the test house operatives will stitch together all those different samples from frequency ranges that have been tested, and will basically get a graph that looks more like this, which you can see it starts at 30 megahertz and ends at 12.75 gigahertz. Of course, it wouldn't be possible to measure it with just one setup, so you can see that the noise floor changes quite dramatically. This is why you get this drops in the noise floor, and then it starts ramping up again. Basically, this is just the preamp that's been connected to the particular setup every time, and at every time that there is a change, that means that there was a change in setup. So then you will see, so this is traffic mode, which has a higher limit, and you can see the graphs for both vertical and horizontal polarization. And then following that, there will be a graph for the idle mode, and you can now see that it is a lot closer to the limit, because the limit is much lower now in the idle mode, and this is just a generic EMC scan, which is very similar to radiated emission measurement that we do for generic electromagnetic compatibility. Then you will get the same table for the vertical polarization, and so on will be repeated for each and every LTE band that you've tested. So this is just about everything that I wanted to talk about in this video, and in the next one we will talk about application of other standards under EN 489-1 ETSI standard that specifies all the EMC standards for conducted emissions and immunity that are largely based on the generic EN 61000 standards, but with a few subtle differences. So, hope you enjoyed this video. Please like and subscribe, and I'll see you very soon.